Alright, today we're talking about solving right triangles. I will learn to use trigonometric ratios or trig ratios to find angle measures in right triangles. So we're looking at the angles. We're going backwards. I'm looking at this first example here. Alright, given that the cosine of A is equal to 24 over 25, determine which angle of the triangle is angle A. So I got these two angles, 1 and 2, and I want to figure out which one of these is actually angle A. Right, and this is kind of easy. We're going to use a calculator to help us figure this out. So first thing I want to do is I want to take this 24 over 25 and I want to go ahead and convert that into a decimal. So dividing that gives me that 24 over 25 is going to be equal to 0.96. Right? And since we're using cosine, I'm going to say that the cosine of, let's say, angle 1. Right, if this is cosine, then that's going to be adjacent over hypotenuse. Right, and then I want the cosine of angle 2. That's going to be 4.8 over 5. And I want to see which one of these is going to get me the 0.96. So again, go back to the calculator. 1.4 divided by 5 gives me 0.28. And then 4.8 divided by 5 gives me the 0.96. All right, so angle 1, the cosine of angle 1 is going to be 0.28. Cosine of angle 2 is 0.96. All right, these two are equal, so I would say that angle A is equal to angle 2. All right, so this one is actually A. All right, next example is the same thing. We're just using the sine function. So again, I want to use a calculator to figure out what 8 divided by 17 is. Okay, so 8 over 17, that's going to give me approximately 0.47. All right, if I round it to the nearest hundredth. All right, and if I'm looking at, say, the sine of angle 1, that's going to be opposite over hypotenuse. That's 27 over 30.6. And then the sine of angle 2 is going to be 14.4 over 30.6. And if I put this in the calculator, 27 divided by 30.6, that's going to give me 0.88. And if I do 14.4 divided by 30.6, that gives me the 0.47. Oops. Okay, so I know then that angle A is angle 2. All right. I'm going to leave this last one, this tangent function. I want you to do that one. All right. If you want to see and check your answer, you can compare that with me. All right. Now I'm looking at some more examples. If you know the sine, cosine, or tangent of an acute angle measure, you can actually use what's called the inverse trig functions to find the missing angle measure. So we're going to start off very simply by using the calculator for this stuff. So again, you want to make sure that your calculator is set to degrees. So again, you hit the mode button. This third row degree has to be selected. Okay. Then what you want to do is you want to hit the second button, and then whatever trig function you're using, either sine, cosine, or tangent, if you look closely, there's that -1 next to the cosine. So that actually is read as the inverse cosine. And all you have to do for A is you just type in 0.87 and then you hit enter. All right, the instruction said you want to round to the nearest degree. So the cosine, the inverse cosine of 0.87 is approximately 30 degrees. Right. Do the same thing with the next example. We want to hit second sine to bring up the inverse sine of 0.85. Right, that gives us 58.2. So if I round that to the nearest degree, that's just 58 degrees. Right. Same thing with tangents. I hit second tangent, 0.71. Rounding that to the nearest whole number is going to be 35 degrees. All right. Using given measures to find the unknown angle measures or side lengths of a triangle is known as solving a triangle. To solve a right triangle, you need to know two side lengths or one side length and an acute angle measure. All right, so we're going to practice doing that. All right, so this next example 5, we want to find the unknown measures, round lengths to the nearest hundredth, and angle measures to the nearest degree. All right, so first thing I'm going to use is I'm going to go ahead and find this third side here, that's ST. Because it is a right triangle, I can just use Pythagorean Theorem, which is a squared plus b squared equals c squared. So let's let that be x for just a minute. That's going to be x squared is plus 5 squared is equal to 5.7 squared. Right, so x squared plus 25 equals 32.49. If I subtract the 25 from both sides, it means x squared is going to be equal to 7.49. I take the square root of that. X is equal to 2.74 if I round that off. All right, so if I put that in the calculator, that's what I get, 2.74. So there's that one. All right, now I need to find my angle measures. So let's say I want to use these two, what's given to me. So I'm going ahead and say T. I want to find this angle T here. So the measure of angle T is going to be equal to either the ratio of 5 and 5.7. So this, if I'm using T, this is going to be my opposite side, and this is going to be my hypotenuse. So opposite over hypotenuse, that's going to be my sine function, but since I want the angle, I have to do the inverse of the opposite over hypotenuse. Okay, and we're going to round this to the nearest degree. So in the calculator, I'm going to hit second sine of 5 over 5.7. Okay, I hit enter. It's 61.3, so that's going to round to 61 degrees. All right. Now let's do the same thing now with measure of angle R. So now I'm going to use this as my reference angle. So that's going to change things up. Now this is going to be my adjacent side if I'm looking at R. And this is still the hypotenuse, so I want to do the inverse cosine. Right? And then adjacent over hypotenuse. Right, so second cosine 5 divided by 5.7. Right, and that comes out to, if I round that, 28.6 is going to round to 29 degrees. Right? And those would be our answers, 2.74, 61 degrees, and 29 degrees. All right, now we want to look at the same idea. Since they gave me one of the angles, what I can do now to make things easier is I can just do 90 plus 58 plus angle D is equal to 180 degrees. All right, so if I had 90 plus 58, and then I take 180 minus 148, that gives me that the angle D is 32 degrees. All right. Now what I want to do is I want to go ahead and find these two sides. So let's let that be X and that be Y. I'm going to use the 58 as my reference angle. So this 14 is going to be opposite and Y is going to be my hypotenuse. So this would be opposite hypotenuse. All right, so that's going to be my trig function sine. So the sine of 58 is equal to 14 over y. Right, so I need to multiply both sides by y. Those factor. Then I want to take y is going to be equal to 14 divided by the sine of 58. That comes out to 16.51 because it says round to the nearest hundredth, so this comes out to approximately 16.51, and that is my DF, or FD. All right, and I'm going to do the same thing with the X. So if this is opposite, X is going to be adjacent. So I'm looking at adjacent and opposite, that's going to be tangent. So the tangent of 58 is equal to 14 over X. Multiply both sides by X. And then so X is going to be equal to 14 divided by the tangent of 58. Okay, and I get that that's going to round to 8.75. So EF is 8.75. All right, so those are the missing pieces of this triangle DEF. All right, for this last example, we're going to do the same things, but we're going to actually put it on a coordinate plane. So the first thing is we need to graph these points, -3, 3. That's our point P. 2, 3 becomes our point Q. And R is going to be -3, -4. All right, so that gives me this triangle here. All right, and it says find the side lengths to the nearest hundredth and the angle measures to the nearest degree. All right, so because this is a vertical line and PQ is a horizontal line, I know that angle P is going to be 90 degrees. All right, because a horizontal line and a vertical line are perpendicular. All right, now let's see. The next thing that would be easy to find, I guess, is the distance from P to R, because all I have to do is count. So from R, that's going to be 1, 2, 3, 4, 5, 6, 7. So that's 7 units. And then PQ, if I count going horizontally, that's 1, 2, 3, 4, 5. So that's 5 units. All right. And then I could find RQ using Pythagorean Theorem. All right, so I know 5 squared plus 7 squared has to be C squared. This is 25 and 49. And that comes out to 74. So if I take the square root of that, all right, to the nearest hundredth, that's going to round to approximately 8.60. Right. Now what's left is I have to find the angles R and angle Q. So this is where I'm going to use my inverse trig functions. All right, and I want to look at from R, 5 is opposite and 7 is adjacent. So that means I want to use my inverse tangent function. So that's going to be 5 over 7. Right, so if I put that in the calculator, the inverse tangent of 5 over 7 comes out to be 35.5. If I round that to the nearest degree, that's 36 degrees. I'm going to do the same idea with angle Q. Now if I'm at angle Q, 7's opposite side and 5 is the adjacent side. So again, I'm going to use the inverse tangent, but I'm going to flip these. Instead of being 5 over 7, it's going to be 7 over 5. Right, so the inverse tangent of 7 over 5, rounding up, that's going to be 50, actually that's going to stay 54 degrees. All right, so that is, let's see, that is all 3 angles and all 3 sides. So we are done.